Hello, everyone. Thank you very much for joining us. I have a special guest today with me here today, Mauricio Aniche. He is the author of Simple Object-Oriented Design, a guide to creating clean, maintainable code, a book with examples in Java. Mauricio, thank you very much for joining us. How are you today?
I'm very good, Mauricio. Thank you so much for the invite.
So you're writing a book about object-oriented design. Why is that important for a developer?
Because a lot of us are creating very complex object-oriented software systems. So think of people doing information systems. A company may be doing a payment system or a company doing an ERP or whatever. If object-oriented was your choice, then you have to model it properly so that it's easy to maintain, it's easy to evolve, it's easy to comprehend. And my book is all about how can you make it in a way that your design gets simple so that you achieve all these things I just mentioned.
Do you think a lot of people choose a specific language, but maybe they don't really use it properly in terms of the methodology they should have had used?
The language itself is something that I try to, as much as possible, abstract from my book. So when it comes to implementation, if you want to use, your Java specific way of doing something or your C# specific way of doing something, I don't touch so much about that in my book. My book is a bit more high level. It's really about how you design classes that collaborate with each other and how you put those classes into modules or components and how those components can collaborate with each other. How can you make sure that a class is always in a consistent state? So on and so forth. So language does play a role in there because you may have different ways of doing this in Java or in C# or in Ruby or whatever language you're using. But hopefully my book works for anyone in any language.
But the idea is that you need to use it correctly, no matter what language you choose. So you have your examples in Java in the book, as for what I recall. But what you say is that the theory you teach in the book applies to any language that uses object orientation. But as a developer, if I choose a language, regardless if it's Java or if it's Python or if it's C#, if it's a object-oriented language, I have to use it properly. I have to use properly the methodology. Do you see a lot of developers maybe implementing a procedural, having a procedural approach with a language that's not designed for that? Or why did you exactly choose to teach this subject in the end?
That's precisely the point, Mauricio, because you have the super powerful language that supports object-oriented design. But a lot of software systems out there, they are just coding procedurally. And procedural programming is very cool, of course, but you can benefit from all the benefits that object-oriented designs give to you. And this is where my book tries to focus, So if you have the chance of using an object-oriented language, let's model things properly so that your system gets easier to maintain. And as you said, indeed, I've seen in my life as a developer, 20 years by now, a lot of people using Java, let's say, but the code was totally procedural. So then you're sort of in the worst of both worlds, because you're not really benefiting from whatever you can have from procedural languages. You're not also using object-oriented design. And people don't do this because they don't know how to use the language, right? They know, everyone sort of knows object-oriented programming by now, but I think it's just very hard to do it. Right? You have some business logic you have to implement. This goes to a database, and then you have all these things in your mind. I have to map my database into my object, and then I have to change an attribute and then persist it back to the database. It's very easy to sort of fall back into procedural way of thinking, instead of modeling objects that collaborate with each other to deliver a more complex feature. So this is where my book tries to explain. And the real focus of my book is this type of information systems, actually, because that's the type of applications I've been developing my whole life. And I try to show to people, hey, you can, in this type of applications, you can still benefit from object-oriented programming.
It's funny, isn't it? Because languages such as Java, for example, even force you theoretically work in an object-oriented way. Like in Java until 21, so up to now, even for the main method, you have to put a class in there. But still developers are tempted to have like normal just methods, having some parameters, returning something. In the end, they might even end up with methods with a lot of parameters. And I think that's, or could be, a consequence of wrongly using the object orientation. No, because instead of like separating that method in a class and having attributes and designing the object, instead they have a method, they put there all the parameters, 20 parameters, and the method does something, and it sounds really procedural. And sometimes even the method is static, so you can't even override it or use it properly, isn't it? And by the way, how do you think this affects the maintainability? And what other non-functional characteristics of an application might be impacted by the fact that developers don't use properly the language they choose?
So first, from your example there of a method with 20 parameters and so, this is definitely a code smell, and that really hurts maintainability. But from my experience, the one that I see more often in information systems that try to that are just coding procedural instead of OO is, let's say you have a table in your database, and then you sort of copy this table into your object, and then you provide getters and setters to all the attributes there. And then let's say you're modeling a basket in an e-commerce, and then you want to add a product to this basket. And then the person is in the controller of the application, because let's say this is a web application with an MVC framework. And then in the controller, the person does something like basket.getItems.add, and then the person passes the item there. So this is sort of breaking all the possible rules in a good object-oriented design, right? Because you're not properly encapsulating this basket. This basket is basically a data structure that just holds data. It doesn't really hold behavior. It doesn't really make sure that all the invariants are there. So let's say the basket has rules like, you cannot have more than 10 items in the basket. Usually people code this type of stuff in the controller, not very close to the class. And this is what procedural programming is to me, right? You're just coding procedures, but you're not really trying to model objects that are responsible for their consistency and life cycle. So this is to me sort of rule number one of object-oriented design that people sort of miss a lot. And again, not because they don't know, but it's just because it's very hard to model things properly. And this to me is what really hurts maintainability in the long run. Because the more you start to code this type of very complex business rules or consistency checks far away from the entity or the place that this needs to happen, the harder maintenance becomes. Because maybe, you create a feature, 6 months later, you need the same business rule, but this is, not implemented in the right way. So you're coding this feature too. You don't remember that this rule is implemented in controller A, everything becomes a mess. So that was the first part of your question. What was the second part of the question?
What other non-functional characteristics do you think might be affected by the wrongly usage of the object orientation? Like maintainability is one of them, but maybe testability or performance or security, would that be possibly impacted as well?
For sure. Testability is definitely one of them that I talk a lot about in this book, and I also talk a lot about it in my first book on testing. One great advantage of a good object-oriented design is that it becomes super easy for you to write tests, right? Because you suddenly have very cohesive classes that don't do a lot, that collaborate with other classes, that properly manage these dependencies, right? So it becomes really easy for you to, hey, let me replace this dependency to a fake one, so they can write the test in a much easier way. So this is certainly one benefit you get when you're doing OOP, and a drawback that you get when you're not doing it, because testability becomes much harder. Security, this is an interesting point. Although I don't use the word security in my book, I have an entire chapter about consistency and data validation, which is somewhat related to security, right? So a lot of what we do is we get input from the external user. We have to then transform this input into something that the domain understands, and we sort of have to trust this input. If you're not doing this properly, it becomes really easy for an attacker to try and inject something in your system, right? So I cannot really prove this empirically, but my feeling is if you're modeling things in an OOP way of doing things, you're paying more attention to consistency and how you handle input validation and etc. And this sort of becomes more natural to take care of these things. In terms of performance, that's a good one. I don't talk about performance in my book because to me, performance touches so many other points in terms of architecture. I feel my experience tells me that design rarely has a big influence on performance, but it's sort of a good exercise for me to think about it. I didn't finish writing the book, so maybe that will become a section in the future chapters.
Oh, that's good. And by the way, what you're talking about right now, it just triggered me something. You know, we discussed a lot about solid principles, single responsibility, list of interfaces, interface aggregation abstractions. There's a lot of fuss out there, and developers already, most of them, I say they know about solid principles, they try to apply them, which is really good, but you can't really apply solid if you don't have, first of all, a well-defined object-oriented app with an OOP language, of course. Because how can you even discuss about the responsibility or having only one responsibility when you don't have, like, you don't really have an object first to have that responsibility in, isn't it? Is that right?
Totally. Everything I say in my book is related to the solid principles. So if you know the solid principles, my book will make a lot of sense to you. And all these things that people talk about, you know, creating a good design that help you evolve and change things. Solid is one of them, but, you know, clean architecture, hexagonal architecture, and etc. We sort of already know these things. My book just gives a different perspective on these principles. And in fact, I link a lot of the patterns that I describe in my book back to the solid. So for example, you mentioned SRP, single responsibility principle. For me, it makes a lot of sense that we need to have classes, modules, whatever. They should have just one responsibility and not many. Everything gets just much better if you're doing like this, right? Your code is simpler, reuse is much easier. It's easy for you to replace that small part of your program to another one if there's a big change and you just have to replace that part of the system.
I see you discuss actually abstractions in chapter 5 of your book. So what do you think defines a good abstraction in any app?
Very nice, very good question. So indeed, I have one entire chapter dedicated to abstractions in the book. And I think to me, abstractions is what allows us to keep changing, to keep making changes in an object-oriented system without having to change 10,000 lines of code whenever we have to make a change, right? So imagine that you have this, you know, we're giving the example of this e-commerce store. So let's say this e-commerce store has discounts and then discounts emerge all the time. So developers have to keep implementing new discounts. If you have a very good abstraction around this discount, then it's much easier for a developer to just go to the code base, create a new class that implements this discount interface or something, and then this new discount will be just plugged into the system. So thinking about abstractions, identifying parts in your software system that you need to extend, so they have to create extension points, is fundamental in a good object-oriented design. Of course, the challenge is you don't want to create interfaces for everything. Otherwise, everything becomes way more complex because abstractions have a complexity cost. They are just more complex than just normal code. So this is where the trade-off becomes interesting, right? And in that chapter of the book, I discuss my personal rules of thumb on when to create an abstraction, when not to create an abstraction.
Yeah, that's a really interesting topic, actually, because in the end, I have seen both cases. So I've seen developers hard coding those conditions there, if else, like your discount example, for example, if and then they don't have an abstraction. Also, they have to change it, and then they just simply add one more else if or a switch or something like that, instead of plugging in some implementation and abstraction. But in the end, I've also seen software where developers create, like, you know, for service classes, they write interfaces, but they only have one implementation, and they will never actually have more than one implementation of that service. So why do you create an interface for that? And yeah, I think it's a very important thing, isn't it, to learn all this stuff and to properly create your code base in such a way in which you would be able later to easily extend it or fix things.
Yeah, for sure. You can make a mistake to both sides, right? You can under-engineer something or you can over-engineer something. And that's where the challenge relies, right? And I think I discuss a lot about this in the book, that the real problem is that when we're modeling stuff, we know very little about what we're modeling, right? We don't have a crystal ball that says, hey, in the future, we are going to have 10 implementations of this, or hey, we're not going to have more implementations of this. So it's pretty hard to take the right decision. And I have one entire section in that chapter that is more about, you should keep refining your abstraction because you're going to get it wrong for the first time. And I actually even cite this sentence from this book that I love, that is called The Philosophy of Software Design by John Osterhout, that he says that in his experience, he only gets the design right the third time he does it. So he codes something and then he sees how it works, he learns, he improves it, and then he gets more feedback from how people are using his APIs. And then the third design is the one that really, works. And when I read that in the book, I was like, huh. And then I started to try and reflect about this, and that is really true, right? So I think that's the challenge that we all face. So I think the point is, we will make mistakes, we will take bad decisions, but we need to keep improving them. Otherwise, we will just create the legacy of tomorrow if we never improve things.
One thing that I'm really interested in, but I didn't have the chance, is to read this chapter 7 of yours, because, well, it's not released yet in the MIP, and I'm still looking forward to it being released. Handling infrastructure. I'm interested, what's the relationship? If you can tell us just a little bit, maybe in advance, what will you tell us about the infrastructure handling and the relationship between infrastructure handling and object orientation?
Yeah, very good question. And to be honest, I created this chapter mostly because I see that this is a huge chunk of discussion, at least in the Brazilian community, when we are talking about object-oriented design. This is where things get very messy and people fight and etc. Right? Because when you're modeling an information system, your information system doesn't live in a bubble, right? So it talks to a database, or it uses some web service, or it needs to do something that goes beyond your boundaries. And then how to model this, right? Because on one hand, you really want to abstract away your database a little bit so that you don't have SQL queries all over your source code. But at the same time, you cannot really hide that you have a database behind the scenes from the developer, right? Because the developer needs to know there's a database behind theirs, and it's a relational database, because then you know what to optimize for, right? You want to also benefit from all the magic that your infrastructure gives to you. So there's a tension there between, I want to hide the infrastructure, but I also need to know what is behind the scenes so that I can take proper decisions. Maybe another example that I think it's a good one, right? So let's say you consume some web service, and then you hide this from the developer, right? For the developer, this just looks like a method call. But well, this is not a method. This is not a local method call happening on the same JVM. So this is a remote call. A million things can go wrong because it's a remote call. So we cannot fully hide this from the developer, right? So I said something on Twitter. I think this was in Portuguese, so maybe hard for people to follow. That's going to go to the book. But I said that a good design hides these decisions in the code, from the code, so that you can easily change stuff, but it doesn't hide the decisions from the developer. So the developer really knows what's going on in the system, but the code doesn't really know everything. So this is the story that I'm trying to tell in this chapter, which is the chapter I'm writing right now, actually. And I feel like this is, again, core in designing information systems using object-oriented design, because you're always going outside your control. You're going to the database, you're going to web service, and you have to model this properly.
Well, that really sounds really interesting. I'm really looking forward for that chapter to be out. It's really true. I've seen this, like, even like a pattern, you see it. People want to abstract things, hide something, but then at the very end, then they end up, hey, I want to also see the details, but it's not possible. You have to be on one side or the other. No, it's like when we go with, we had virtual machines, and then we created containers, and then now we have serverless, and now we have serverless functions, but we want to do stuff that you can only do on the VM level. So hey, when we decide to have containers or having Lambda functions, then you made a compromise, isn't it? And I think this is also something that we can make at even the low level of the code that we write.
Exactly. So the real challenge there is to decide what you want to abstract and what you don't want to abstract, so that the person has to focus on the concrete details. And this is where the tension happens, and it's why it's so cool, right? As a developer, this is why it's so cool, because you have to really think about how to design these things.
Cool. Mauricio, I already learned a lot of things today from our discussion, and I don't want to keep it longer. I want to allow our viewers to like read your book and find out all the details, because we can't simply talk in 20 minutes about everything. Is there something at the end of our discussion that you'd like to tell your readers and of course our viewers now, or our listeners, depending on how you guys are taking this discussion? Is there any advice or anything that you feel important to mention to them?
I think I want people to read the book, see if my patterns match their personal patterns, and if they have some ideas there that I didn't cover in my book, to please send it to me, because I'm really curious about how people are developing object-oriented systems for information systems that are easy to maintain. So please drop me a message if there's something in my book you agree or you disagree, or there's something that you do differently that I didn't mention. I'm very curious to hear about you all.
Thank you very much, Mauricio. So guys, remember to follow Mauricio on Twitter, and of course, get his book and read it. And he's looking forward to your messages. And I'm pretty sure that you will learn a lot of things. I have learned a lot of things already. And it's always good to share views and opinions. So even if maybe you will not be they will not match yours, that doesn't mean they are not right, and that doesn't mean we don't have flexibility in different cases, because that's what software development is in the end. Thank you very much again, Mauricio. Hope to maybe see you soon, even in person, and of course looking forward for the next chapters of your book.
Thank you so much. Bye.